Hello, my friends, and welcome. I hope you're doing fine. And today we will have a look to the next exercise of Exercism. It's called Resistor Color. Let's go. Let's do this. All right. So, as you see here, actually our next exercise is binary search tree, but I'm still working on that. So we will skip that and we will do this one, Resistor Color. So basically in the old version of Exercism, all of this, starting from Hello World to binary search tree, it was the main track. And all of these, starting from Resistor Color to matching brackets, it was side tracks. Like in the early version, you needed a mentor to say, okay, this, for example, anagram, it's good, so you can do the next one. So you need to wait for a mentor to do that. So you need to do all of that. But this one, it was like sidetrack. You can do whatever you want. Okay, so let's see. Resistor Color. Instructions. If you want to build something using a Raspberry Pi, you will probably use resistors. Okay, so for all of you who don't know what Raspberry Pi is, so basically it looks something like this. And yes, it is smaller. Well, it's basically the same size as a Visa card. It's smaller than a phone. It's like this. So it's basically as big as a Visa card. And it's a full functioning PC. So you can really just plug your Ethernet, your peripherals, like your mouse and your keyboard, and then plug in your monitor, and then you can use it. Like, it works right away, and it's really cheap. I don't know which, like this, they have Model 4 now, and the earlier version, it was $25. So it was really, really cheap. So the idea behind this is to to bring programming, and especially like microcontroller programming, to students. So also for kids. So kids can, put some code and then see. For example, they had microphones and lights and stuff like that. So basically, let me see. For example, here you have a display, so you can do something with that, or need something simple. All right, I don't find something simple on the go. So basically, all right, whatever this is, or yeah, let's say this one. For example, you can connect this is a camera, for example, and so on. So you can do everything. So you can, because you have the I/O on this side, and then you can program them and do whatever you want. So it's a really, really cool thing. And yeah, so if you're using that, it's cool. All right. So the second thing is, if you don't know what resistors are, so basically they look like this. I will not tell you what the function is of resistors. If you're not interested in electronics, so it doesn't make sense to say. But for this exercise, it's interesting to know that they look like this, and it's basically in every device that you own, even your phone. And the bigger ones, they look like this. They are really small, but I'll call them bigger ones because I will show you another version of these. So they have colors on them, and this is basically the resistor color. So this is what we will do today. So based on the color, you can have the value of that resistor. For example, they have here You see, you have yellow, violet, black, brown, and if you add all of them together, you get 4.7 k ohm. Okay, so it's basically you have this table, and then you just look it up, and then you know, okay, this resistor value is 4.7 k. Okay, so I wanted to show you the second version of resistors that nowadays they use in smaller devices. It's this. So you see how small they are compared to the ones that we saw. These are really small. Like, they are really small. All right, so cool. So let's read. For this exercise, you need to know two things about them. Okay, each resistor has a resistant value. Okay, that's what we said. Resistors are small. That's also what we said. So small, in fact, that if you print the resistance value on them, it would be hard to read. Okay, it's whatever. We saw that you can print something on them, but all right. To get around this problem, manufacturers print color-coded bands onto the resistors to denote their resistant value. Each band has a position and a numeric value. Okay, this is what we said. If we go back here, so you see position is important because this is the first position, this is the second position, and then you see you have different versions. You have one with 4 and one with 5. So the 4 version, it has like a multiplier and tolerance. The 5 version, it has first, second, third, and then multiplier and tolerance. Okay, but all of that is not important for us because what we need to do, I'll skip all of this because we talked about that. So basically what we need to do is, the goal of this exercise is to create a way to look up the numerical value associated with a particular color band. So basically, if they say yellow, you say 4. If they say violet, you say 7. If they say orange, you say 3. Okay, that's all what we need to do. That's the first thing. And the second thing, to list the different band colors. So basically to print out the colors. Okay, that's all what we need to do. Nothing more. If you need to read about resistors and whatever, so they link the Wikipedia page down here, and then you can read. All right, so I'll close over that. We don't need them. Cool. So let's copy that. Let's open terminal. And then let's paste that in. Come on. All right, let's copy and go there. And then let's first lib. And then we need the test one. All right, cool. So in the resistor color.dart file, you see that we have a class. It's called resistor color. Let me make this bigger. All right, so let's make this also bigger. Cool. So in here we see that we need a method that's called color code, and it takes as a parameter string. If you see, these are all strings, and it gives back an integer as a result. Okay, as we said, like red, whatever, black, I think black is 0, brown is 1, and something like that. So yeah, oh yeah, you see it, black is 0, white is 9, orange is 3, and so on. And then you need one more thing, and to list all the colors. So you have this one. Okay, basically it's a small one. It's yeah, it will be a fast one. All right, so let's keep this one here and go to Dartpad, and let's try to do it. So we said that we need a class that it's called Resistor Color. Let's copy that. Always copy paste to, yeah, to avoid like misspelling errors. So it will be, or mistyping, whatever the correct way to say. All right, so we need color code. So int color code, and that gets a string as a parameter. And let's call this one, what did I call it? Selected color. Yeah, of course. Selected color. So, because this is the selected color that we selected here. Like, we selected black, so we get it here. Okay. So, what do we need to do? So first thing we need to, let me close this. We need to list all of the colors. So basically we need to create a variable, basically an array, to list all of the colors. I did that beforehand, so you need to type all of this by yourself, but it's easy. And the most important thing is here in this array, the position. So don't put brown in here and violet in here and red in there or whatever. The order is very important because, you know, in array you have this position is 0, this position is 1, 2, 3, so on and so forth. Okay, so don't basically don't mess up the colors. This is the order, stick to it, it's important. All right, cool. So the next thing is we need to make this work. So we say return, basically we need to return an integer, and then we need to select a color. So the most easiest way to do that is if we say colors. So basically this is the colors, and then we say, okay, you chose selected color, that's the index of it. So if it's black, the index of black is 0. The index of brown is 1. Okay. So let's see. We said index. There's something called index of. So it takes an element, and the element is a string. So the string is black. It will give back 0. Okay. And it starts at 0. That's cool. You can also use index where. So it makes a function which is like more to avoid more errors and something like that, or you can add you can expand on the functionality. So you can use index where. So that's also a good one. But in this example is very, very like basic and easy. So we will use index of. Okay. And then we say basically selected color or parameter. We put it in here. And yeah, that's it. So let's call all of that. Var, let's call RC for resistor color, the class. So let me copy this. Cool. And print. So RC dot. So the first thing is what we need to do. We said that we need to call our function and give it a string. Okay. As they do it here. So the first string is black. So let's copy this one. Or whatever, let's take yellow, for example. It's in the middle, so it will be 0, 1, 2, 3, 4. It should give us 4 back. Okay, not here, and here. Okay, so let's run the code. Let's see, it should say 4. Yeah, 4. I need to click run twice somehow. All right, 4. Cool. If we say violet, for example, so we have 0, 1, 2, 3, 4, 5, 6, 7. I should say 7. 7, yes. Okay, cool. So basically that's the first thing that we need to do. Let's go there. This is our to-do list. All right. Basically it works. Perfect. What is the second thing that we need to do? We need to go here. Sorry. To list the different band colors. Okay, so we need to give it back all the possible colors. Cool. How we need to do that? So we need to print it, of course. So rc dot. Okay, how can we do this? So the easiest way to do it, we need to give it access to colors. Okay, but colors now it's inside of this method, so you don't have access from outside. So the easiest way to solve this problem is to make it global, to put it outside that method. And now if you say rc dot, you see colors, and if we run this, you get all the colors. That's it. That's basically all of it. Don't make it complicated. Don't make like, I was thinking you can try to solve this exercise with map. So basically you can do that as well. So in map, we learned about map, you can say black is 0, brown is 1, red is 2, and so on. And then you can order it as you like, because it's a key and a value. It doesn't matter. So if someone gives you the key, you say the value is whatever, okay? You can do that as well. The only problem will be the colors. Like if you have it in a map, yeah, you need either to define another method, but that method does not exist in the test file. So basically you will do two things. You will do this one, and then you will add a map as well. Yeah, so, but the possibility is there as well. So you can solve it like that. All right, cool. So let's copy this and let's paste it in here. Save. Where's my terminal? Here. Okay. So dart pop get. So let's get all the dependencies. Dart. Okay, before we do that, let's change this kips. So it is false, false, false. Save. Terminal. Dart run test. All right. So let's see. And all tests passed. Perfect. So this is how you solve this resistor exercise. So I hope you learned. I know it's very basic and it's very easy. So if you did if you watched all the videos until now, you would say this is really easy, but it's okay. It's another exercise of exercism, and I hope that you learned something. And I see you in the next video. Steve out. Ciao.